Good morning, students of physical science energy. Today I'm going to be recording a lecture on the metric system and measurements. Let me get to present mode real quick. All right, these slides are going to be made available to you as a study tool. For this lecture, our agenda is first I'll be talking about the introduction to the metric system. Then I'll go into scientific measuring tools. I'll talk about accuracy and precision. And then we'll talk about the metric staircase and how it is easy to convert between units of the metric system. And finally, we'll cover how to do a conversion problem. Wanted to share this song created by other students of science with you. It's usually a hit in the classroom, and I think I figured out how to get a song to work on this video. So I'm not gonna press the play button here, but if you wanna watch the song later, it'll be available on the slides. Now you don't have to cram for your exam on the metric system. Meters, liters, and grams. Now you don't have to cram for your exam on the metric system. Please, you can measure a distance like the height, mad, tall, or super small. One of these will do you right. If you try walking a meter, it's easy to compute because a meter is just a little bit more. If you walk in a kilometer, it's gonna take a while. It's 1,000 meters. That's over half a mile. A centimeter's making the width of your pinky. There's another kind of meter smaller than that. It's not very fat. It's called a millimeter, in fact, and it's tiny. 1,000 of them in a meter thick. That's 10 in a centimeter. That's it. As liters and grams, now you don't have to cram for your exam on the metric system. Meters, liters, and grams, now you don't have to cram for your exam on the metric system. Measuring liquids and containers. We only got two. It won't take long to explain this. A liter is half a big bottle of soda pop, and a milliliter is just about 20 drops. There's 1,000 milliliters in a liter, you know. So if you got both of these, you can go. For now, we can move on to grams. Measuring weight, kilograms, milligrams. Yeah, we keeping them straight. It's pretty simple. A paperclip, a textbook is a kilogram, man. But a milligram is a little harder to fight because 10 milligrams. Is a gram, 1,000 grams in a kilogram. Now we got grams, we also got liters. Liters and grams, now you don't have to cram for your exam on the metric system. Liters and grams, now you don't have to cram for your exam on the metric system. All right, hope you enjoyed a little bit of music there. Okay, so our essential question for this unit is, what is the metric system? Another supplemental question to go with that is, how can I make precise and accurate measurements with the metric system? It's a very important science skill in order to make measurements. So the metric system is the system of agreed upon measurements in the STEM, science, technology, engineering, and math community. It is a system of measurements based on the powers of 10. The metric system uses common base units for various types of measurements. And these base units, you heard a little bit of them in the song,
For length is meters. For volume is liters. Mass is grams. And time are seconds. Okay, I wanted to pull this map up first. It shows the green countries utilize the metric system, and the red countries utilize the English system of measurements. As you can see, the United States is one of the countries that still uses the English system. Liberia is another country that uses the English system. And Myanmar, over there by Thailand and India, is another country that still uses the English system. The rest of the world, like 97% of the rest of the world, uses the metric system. Those are the green countries. So this is a map that shows you the countries that use metric and the countries that use the English system. Even the English don't use the English system anymore. So I put a text box here. It says, hey, we're in England. Don't we use the English system? And the answer to that would be no. So the first thing I want you to think about today for your assignments is, why doesn't the US switch to the metric system? I want you to look at this world map closely and answer these 3 questions in your drag and drop notes this week. The first question being, do you think the United States will ever change to the metric system? The second question, what are some benefits associated with this change? And the third question being, what are some of the possible challenges associated with changing from the English system to the metric system? And you'll answer these questions in your drag and drop notes assignment for this week. So the first scientific measuring tool I want to talk about is the measuring tool that you would use to measure a length. If you're talking about something that's around 30 centimeters long, or about the length of a ruler, you would use a metric ruler. One metric ruler has 30 centimeters. It also has 300 millimeters, because there are 10 millimeters for every centimeter. So here is our metric ruler. Another scientific measuring tool you will need to know is the meter stick. Meter stick, I think this guy is going to appear in a lot of our assignments today. We'll call him Metric Dave. Metric Dave here is holding a meter stick, and it is about this long. It's the best picture I could find of a meter stick online. It is 1 meter. There's also 100 centimeters in a meter stick, and then therefore there's 1,000 millimeters in 1 meter stick. The scientific tool you will use to measure volume, liquid volumes, is a beaker. This is a 50 milliliter beaker. They come in all sizes, even up to 200 milliliters or 500 milliliters if you needed to measure larger volumes. And then if you need to measure smaller volumes than that, say less than 20 milliliters of liquid, you would use a graduated cylinder. And here are the graduated cylinders over here. And they come in also various sizes. I think this one over here is 100 milliliters, 50 milliliters, 25 milliliters, and then this must be like 10 milliliters over here. The scientific measuring tool you use to measure mass, not weight. Don't confuse these 2 properties. Mass and weight are very different things. Mass is the amount of stuff or matter in an object, and so we measure mass using an electronic scale. This is the new age method to measure mass. It's way more accurate than the old school method for measuring mass. This is called a triple beam balance, and if you've ever been to maybe the doctor's office and they put you on an older scale, they have to move the weights back and forth in order to get your weight to even out with the weights on the balance. And this triple beam balance works just like that. And so I usually have students practice with a triple beam balance, but this is what that looks like. All right, the instrument you use to measure time is called the stopwatch. You can see stopwatches have come a long way. They used to be mechanical stopwatches, and then back in my day they were analog watches, and nowadays you use digital stopwatches on your cell phone. And as you can see, this got more accurate as our technology got better, kind of relating to last week's lesson. As our technology gets better, our accuracy in science is also able to get better. Okay, so talking a little bit more about accuracy and precision. Choosing the right scientific tool is the first step to making accurate and precise measurements. However, we as scientists can only ever be as accurate and precise as our tools. In this way, scientific tools for measurement should really be considered scientific instruments like musical instruments. I thought that the students who are in band could relate to this. Just like musical instruments, scientific instruments must be tuned to play the right tone or adjusted to be accurate. So if you're in band and you know that you have to tune your musical instrument, the same thing has to be done to scientific instruments. We have to make sure they're calibrated or adjusted to be accurate. So they're measuring the correct value. To be accurate means to be correlated or lined up perfectly with the accepted true value of a measurement. To be precise means to be able to reproduce the same measurement repeatedly. So there's a little bit of a difference between the words accurate and precise. Okay, now I'll talk about precision. Oh, this question is great. Can data be accurate but not precise? And then you also may be thinking, can data be precise but not accurate? And yes, it can. So I like to explain this in a story. So it's time for a story about playing darts. Okay, I used to play darts in my friend's basement, and I was getting better as I was playing darts. Round one, I wasn't very good. I had low accuracy and low precision. Let's say that the true actual accepted value of any measurement is the bullseye. So relating this back to science, if I have low accuracy and low precision, I'm not very precise or accurate, I'm not going to have any of my darts hit the bullseye. I'm not going to have any of the darts hit the other darts that landed on the board. This is like when you're first starting to play darts and you're not very good yet, so you're not very accurate and you're not very precise. Well, then I practiced some more, and I wasn't getting very accurate. I wasn't hitting close to this bullseye, but I was getting pretty precise. I could hit the same area of the bullseye over and over again. So then I adjusted, and for round three, I had high accuracy. I got closer to the bullseye, but I had lower precision. I wasn't able to get all of my darts to hit the same spot over and over again on the bullseye. Well, after all that practicing, I got really, really good. And round four, I had high accuracy and high precision, which means I was hitting the bullseye over and over again, and I was being very accurate and very precise. This is the kind of data that's the best kind of data in science. You want to be able to have repeatable, accurate measurements that are also precise, and so you're hitting the bullseye over and over again, or you're hitting that true accepted value over and over again, being precise and accurate. Okay, so the next step is choosing the right metric unit and prefix in order to be precise. Here's an example. So let's say you're measuring the length of a bumblebee. The length of a bumblebee is less than a meter is a bad example of an accurate measurement. A meter is like really long. So if you say the length of a bumblebee is less than a meter, that's not a very accurate or precise measurement. It could be this big or this big or even bigger. A better example of an accurate and precise measurement is the length of a bumblebee is 0.015 meters. Now, that's a lot of numbers to say, and we can make this easier on ourselves by using a metric prefix. So the best description of this length of a bumblebee would be the length of a bumblebee is 1.5 centimeters. This is the easiest number to say, and we're using a metric prefix in order to be more precise and accurate about the measurement that we made. Here's another example. Let's say you're measuring the mass of a car. A bad example of having an accurate and precise measurement is the mass of the car is 2 million grams. Well, 2 million is a big number, and it's hard for us humans to imagine any numbers that are bigger than 100, even bigger than 10. So we like to keep our numbers in science from anywhere from 0 to 100 in order to visualize it better. Even the thousands are easier for us to picture. So the good example of this would be the mass of the car is 2,000 kilograms. And by adding this metric prefix, I made this number smaller, so it's easier for me to visualize, and this is the best accurate and precise measurement for the mass of the car. Okay, now we're going to talk about some base units of the metric system. Review this before we get into metric prefixes. I'd like to talk about real life examples so you know what a meter, a liter, and a gram are. So for length, a meter is 1 meter stick. It's about the size of 1 English yard. So here's metric Dave, and he's holding up our meter stick again. It's about 3 feet or 1 English yard. Volume, a liter is about half of 1 big 2-liter soda bottle. So if you picture a 2-liter of soda, a liter is half of this, or this is 2 liters of soda right there. For mass, a gram is the mass of about 1 large paper clip. So if you have a paper clip at home, put it in your hand, and that is the mass of about 1 gram. Time, people are pretty familiar with this one. A second is the unit we use for time in science, and it's about the time it takes you to say 1 Mississippi. Okay, so a metric prefix is a word or symbol placed before a unit that multiplies that unit by a power of 10. Prefixes can be applied to any base unit in the metric system. You will have this table in your metric system and measurement vocabulary list notes this week. So a kilo, the prefix kilo is abbreviated K, and it is 1,000 times larger than our base units. The prefix hecto, the abbreviation is H, and is 100 times larger than our base units. The prefix deca, the abbreviation is capital D, and it's 10 times larger than our base units here. Our base units of a course are just multiplied by 1. So if you're talking about a meter, that would just be multiplying by 1. You don't have a metric prefix that goes in front of your base units. Deci is little d, and I like to think about a decimal. A decimal is a point, and then it expresses a number that is smaller than 1. And so if you think of deci being like a decimal, it is 1/10 or 0.1 times smaller. And this is the first metric prefix that has a decimal in it. Centi is abbreviated little c, and it is 1/100th or 0.01 times smaller. I like to think about this one in dollars and cents. If you think about pennies, 0.01 is the value of a penny. So that's how I remembered centi is 0.01 times smaller. Milli is abbreviated little m, and it is 1/1000th or 0.01 times smaller than our base units. These are the 6 metric prefixes that I really want you to know, and these are the ones that you're going to be tested on. There are more metric prefixes than this. For example, nano is a metric prefix, or micro, and those are larger and smaller then there are metric prefixes that are larger and smaller than just these. But these are the 6 I really want you to know. Okay. Converting between metric units is easy because the metric system is based on powers of 10. So if you start right here with these pink words, meter, liter, and gram, these are your base units. If you wanted to talk about anything larger, you would multiply by 10 this way to larger for kilo, hecta, and deca. If you want to talk about anything smaller, you'd be dividing by 10 as you went smaller this way. Okay. So how do I remember the order of the metric prefixes? This metric staircase is a really useful tool for remembering the order. As you can see, kilo is over here. These are the largest metric prefixes. Hecto, deca, base, deci, centi, milli, smallest metric prefixes over here on this side. A mnemonic device is a tool that you use for memory, for learning, and it helps you remember the order of something. So, of course, there is a couple of mnemonic devices for the order of these 6 metric prefixes. The first one I want to share with you is kangaroo helps dingo because dingo can't multiply. So here's kangaroo, and kangaroo is saying, and here's dingo, and dingo is saying, I need help with my multiplication tables. And kangaroo is saying, I can help you, dingo. And as you can see, kangaroo is kilo with K, and kangaroo goes with kilo. Helps goes with hecto, dingo with deca. Because is our base units. Dingo again is the D for deci, and can't, it has a C for centi, and M has a multiply has an M for milli. So as you can see, this story, kangaroo helps dingo because dingo can't multiply, would help me remember the order of the metric prefixes so I can get the order right every time. Another mnemonic device for metric prefixes that you might like better is King Henry died by drinking chocolate milk. So the same thing applies, KHDBDCM. And here's the picture of King Henry. And he says, oh no, I drank too much chocolate milk. So if you can think of a story to help you remember the order of something silly like this, it really is a good memory device for remembering it on a quiz or a test. I'm going to want you to create your own mnemonic device in your metric system drag and drop notes. And I encourage you to be creative and make me laugh. Okay, so more on converting. Converting between units is easy because the metric system is based on power of 10. If you wanted to go down in the metric system, you're actually multiplying by 10 because these units are smaller. Okay, so if you wanted to convert from a meter to a centimeter, you're actually going to multiply by 100 because a centimeter is 1/100th of a meter. If you wanted to convert up, you're dividing by 10. Oops, I need to go back to that slide. So if you wanted to convert grams into kilograms, you would divide by 1,000 because there are 1,000 grams in 1 kilogram. Okay, so that gets a little bit tricky because as you're getting larger, you're dividing, and as you're getting smaller, you're going to need to multiply. This is how I set up metric conversion problems. It is like a fail-proof way of getting the metric conversion correct without thinking about which way to move the decimal. Okay, so first, my first suggestion for how to solve a metric conversion problem is to read the question. So you're going to read 10 milliliters is equal to how many liters? So we're trying to convert from milliliters into liters. The second thing we'd want to do is think about how many liters are in a milliliter or how many milliliters are in a liter. So we're going to find a conversion factor. That's like an equivalent measure of how do these things compare. So I find out that there's 1,000 milliliters in 1 liter, okay? You could use this from your metric staircase over here, that there's 1/1000th millimeters in a meter. So you would know that there's 1,000 milliliters in 1 liter. Okay, it takes 1,000 of these little small units to make up a big one. Third, you're going to set up the conversion problem to cancel your units. Okay, so I like to start with this bar and a multiplication sign and another division bar. Okay, so on the top here, you would set up your first information that you know. This first part of the conversion problem is what you know. So 10 milliliters divided by 1 is still going to be 10 milliliters because anything divided by 1 is still itself. So this is what we know. Then we're going to multiply it by our conversion factor. Okay? The reason why I chose to put 1,000 milliliters on the bottom of my conversion factor is because I want milliliters to cancel. Just like 5 divided by 5 is equal to 1, milliliters divided by milliliters is also equal to 1. So this unit actually cancels. What I'm left with then is 1 liter, which is great because I want my final answer to be in liters. So it's going to divide or it's telling me to divide or multiply according to the setup. As you can see, milliliters cancels, and then we would get 10 divided by 1,000, since the 1,000 value is in the bottom of this fraction. You would get 0.01 liters. 10 divided by 1,000. If this 1,000 milliliters is in the top of your fraction, you're going to multiply. Oops, going too fast. Okay, so I'll do more examples of these with the metric Kahoot. It's not a skill that I need you to master, but you're going to need to be introduced to this concept because it's a really important concept in physics and in chemistry and in biology. All sorts of science uses conversions, and it's a really useful skill to be able to do one of these. I suggest doing it this way. There are examples in your book on converting units on how to do a metric conversion problem this way using dimensional analysis. Okay, another thing I'm going to want you to do in your drag and drop notes are fun animal facts. Here's an example of what I would like that slide to look like. My favorite animal is a blue whale. So I would do some research about a blue whale and then say that I found out a blue whale is 29.5 meters long and eats 3,600 kilograms of krill every day. So I said that you could tell me 2 animal facts, but the animal facts must include metric measurements. All right, so you're finding fun animal facts about your favorite animal that include a metric measurement. So it has to have grams, meters, liters, something that is a metric system related. And then include a picture of your favorite animal that'll help you describe your facts. Okay, so that's the end. You should complete metric drag and drop notes, the Google slide activity, as well as 2 Kahoots to complete your classwork for this week. I'm going to change over to the assignment sheet so I can talk about what you are supposed to do this week. Okay, so here is your weekly student classwork. It has our EQ at the top. What is the metric system? How do I make accurate and precise measurements with the metric system? Before you watch this video, I wanted you to watch Bill Nye introduce the metric system. He has a really short 3-minute video that was edited by another teacher that will introduce you to the metric system. And then I covered things that you need to know in addition to this other video. So I also want you to do Ed Puzzle of me making this video on measuring tools, accuracy and precision, and conversions. Then after that, I would like you to review the Google Docs, metric system vocabulary and slides. I'd also like you to do some reading in your online textbook. And we're going back to chapter 1 to read about measurements, time and distance, and converting measurements. This is 3 sections, but it's only 9 pages total that I want you to read. So this should only take you about 20 minutes. I want you to do the metric system drag and drop notes activity. This will be the main activity that I grade for points this week. And then I want you to do 2 Kahoots this week. Rather than doing a lab, we don't have any lab this week. I couldn't find a lab that I liked that went with measurement, which is unfortunate because I think measuring is one of the most important science skills that you learn. But we're just doing the best we can with this online distance learning. So Kahoots are your activity this week. The first Kahoot is an easier Kahoot. It's on metric units and measurement. And then the second Kahoot is more of a challenge, and will ask you questions about metric conversions. I encourage you to do these Kahoots as many times as you want in order to help you learn. The last thing you should do this week is take the quiz. The quiz is on quizzes like we've been doing. It's on metric system and measurement, and it will be less than 20 minutes. Less than 20 questions, should take you only 20 minutes. There will be a few conversion problems on this quiz, but they won't be any hard conversions, just using the 6 metric prefixes that we've talked about in this video. So to show you what these things look like, here's the Ed Puzzle. This is the introduction to metric system, Bill Nye, the one that I want you to watch. It's about 3 minutes long. Here are your drag and drop notes for this week. I want you to start by answering this essential question just by typing in this text box. This is like your thoughts here. I want to see what you can summarize from this video and from the reading about this essential question. Then you'll be answering these 3 questions about why doesn't the USA switch to the metric system. You'll be doing a couple drag and drop. These move around, and you can drag and drop the science tools into the right type of measurement that you would do. Okay, and then also measurement tools that go with the right unit of measurement. So which units would you use for which one of these tools? I want you to also give me a bad example of a measurement that is inaccurate, precise, and a good example of a measurement that is accurate and precise. So use this Drake meme to type a good and a bad example of an accurate and precise measurement. This is another drag and drop activity. You can move the metric prefixes and the values, and I want you to create your own metric staircase by dragging and dropping the prefixes and values in the correct order. Then you're going to make up your own mnemonic device to help you remember the order of the metric prefixes. Remember, a mnemonic device helps you memorize the order of something by including rhyming or storytelling. You can also include a picture, but that's not required. Picture usually helps you remember the story. For example, King Henry died by drinking chocolate milk, or kangaroo helps dingo because dingo can't multiply. Create your own mnemonic device with your own silly story for this slide. Okay, you're going to do some converting units, and you can drag and drop these values over to the right conversion to make it an equivalent or an equal measurement. So you would need to know how many milliliters there are in 1 liter. and then you would drag and drop the correct value to make that correct. You would need to know how many centimeters are in a meter, and then drag and drop the correct value to make this equal, and so on for the rest of these 6 problems. These values are the only ones that you should use. You don't need to copy and paste them. There should be all the ones here that you need. Okay, and then the last part of the drag and drop activity are the fun animal facts. I want you to insert your own picture here of your favorite animal, do some online research for some fun animal facts, and then write 1 to 2 full sentences that include 2 metric measurements to describe the animal's size, habitat, or food requirements. So you can type here, and you're welcome to use the start of this sentence. If you would like, you would say, like, I researched blue whale. I discovered that the blue whale is 29.5 meters long, and so on and so forth. So you include 2 animal facts in this text box. Okay, I'm gonna make these. This should actually be complete 5. Sorry, I never changed that. Metric drag and drop notes and the 2 Kahoots. I'll make these slides available to you this week if you would like to review on your own the slideshow that I did this video from. Sorry, things in my way. Okay, here's your metric system and measurement vocabulary list. I would like for you to read this, and I saw a number of you on the vocab list from last week add your own highlights. This was really helpful to me that I knew that you had looked at it. So the highlighter tool is right up here by all of your menus for text. If you wanted to choose yellow, highlight, and then highlight the words that you need to remember, it will let me know that you have reviewed this and that you read it, okay? Otherwise, these are just notes for you to help you understand the material. The notes this week come with a couple tables. This would be a super helpful table for you about conversions because it includes the equivalent measures. So it tells you that 1 millimeter is equal to 0.01 meters. It tells you that 1 milliliter is equal to 0.01 liters. This would be helpful for you when converting. And then it also includes a table on the physical properties with their base unit that you would use to measure for the metric system, and what abbreviation we usually use to go along with these base units. So for meter, it's M. For meter squared, it's this little M with a squared or the exponent of 2. For a volume of a solid is meters cubed, so little m to the 3rd power. Liter gets a capital L. Gram for mass gets a little g. Seconds for time gets a little s. And then these are 2 units that we'll talk about later on in the course. Energy is joules and gets a capital J abbreviation, and force is measured in newtons and it gets a capital N abbreviation. So just introducing you to these 2 at the bottom. Okay, our metric prefixes, there's also the table here for you on metric prefixes, and it tells you how many times larger or smaller each of these metric prefixes are compared to the base. Okay. I will need you to read the book this week. Like I said, it's 9 pages. It'll really fill in the gaps to your understanding of what wasn't covered in the videos. It's pretty good. There's only 9 pages to read. So you're going to start on chapter 1. You're going to read measurements. You read this section. There's that table again that we included in our notes. I like this table too about the amount of information for computer and data storage. So the SI base unit for information storage is a byte, and a kilobyte then is about a half a page of text. A megabyte, getting even bigger, is 1 minute of music or 500 pages of text. A gigabyte is 1 billion bytes, so 1 billion times bigger than a byte. And it's about 18 hours of MP3 music or 12 hours of flash video. A terabyte is 1 trillion bytes, 1 trillion times bigger than a byte. and it's about the information that the Library of Congress has, is about 10 terabytes of print collections. Petabyte is 1 quadrillion bytes of information, and this says an internet search engine processes over 20 petabytes of information a day, or it's about 700 years of full HD quality movies. So 1 quadrillion times a byte is a whole lot of information. Here's another useful table for you that has the SI prefixes that are smaller and larger. So this that I really want you to know is from kilo to milli, but this also, if you were curious, has the smaller metric prefixes and the bigger metric prefixes on this table. Okay, I want you to read about accuracy and precision to fill in your knowledge. You can skip the review page, then you're going to read about time and distance. You can skip this page about distance of units in space. We cover this in Earth and Space Science, so you can skip those pages and then skip the review. And then I also want you to read about converting units. This will really help fill your knowledge in about how to convert metric measurements. And they include how to move the decimal back and forth, and then also how to solve using dimensional analysis. Okay. Let me remind myself, all right, we talked about the online textbook, we talked about drag and drop notes. Oh, the Kahoots. Oops, sorry, I was covering my microphone. The Kahoots are these 2 Kahoots. You'll do metric units and measurements. Kahoot. Pretty sure this will be a pretty popular activity. I want you to do the Kahoots as many times as you need. They're both 15 questions. One's easier than the other one. Metric units and measurements supposed to be the easier one. And then metric system conversions is a little bit tougher. But like I said, I just want you to do these as many times as you can in order to learn better. Okay. Great, yeah, here's and it comes with a metric conversion chart on every answer that asks you to do a conversion. Okay, so 15 questions for both of those. Very last thing you need to do is the quiz. Like I said, the quiz is worth 100 points, but it's 20 questions or less. The reason why the quizzes are 100 points is because your grade in this class is weighted. So all the quiz scores are only 30% of your total grade. So if you do all of your other assignments, let's say you do all your other assignments, the labs and the other assignments besides the quizzes, that would give you a 70% in the class, which is a passing grade. So the 30% quiz score of your grade is really how I'm assessing how you're learning each week. And even if you don't do well on the quizzes, you can still pass the class. So just to alleviate some of that stress with the quizzes being 100 points, it is a weighted grade, so it's not going to affect your grade as much as if you do the assignments and the labs. Really want you to do the labs and the assignments first, and then do the quiz last. All right, I think that's it for this lecture. Let me know if you have any questions. I am available on Zoom or Google Meets for office hours. We're trying both platforms, but I'm available from 1 to 2 on either platform for questions, Monday through Thursday. Or you can email me and we can set up our own Zoom appointment. If you're worried about having other people hear your questions or need help and you don't want other people to know what you need help with, I'd be happy to set an office hour up with you one-on-one so I can help you on Zoom with some of these assignments. All right, I hope you learned a lot about the metric system and I hope you have a great week. Bye for now.